Hello everyone, welcome to Free License class. This is Purnima and today we are going to discuss some problems related to pH. So if you are new to my channel, please don't forget to subscribe my channel and also click on the bell icon so that you will get notification when I upload new videos. Okay, moving into the first question. What is the pH of a solution of 0.36 molar HCl, 0.62 molar NaOH and 0.15 molar HNO3? So, how to solve this question? How to find a pH of a solution? So, in the solution, you can see there is HCl, sodium hydroxide as well as nitric acid. So there are two acids and one base is there in the solution and they are asked for finding the pH of the solution. So we have to find the pH of the solution. So to find that we have to calculate the correct molar concentration of acid and base in the solution. That is, we have to find the H plus ions, the number of H plus ions and OH minus ions in the solution. Then only we can find the pH. Okay, how to find that? So, for finding this is the way we have to find. So in the solution it is given that HCl and nitric acid are there and they are strong acids. So, and one thing that is the sodium hydroxide is a strong base. So there are two acid and one base. So the total H plus ions in the solution from two acids are, just add the 2 molar concentration of acid, 0.36 molar HCl plus 0.15 molar nitric acid. So we will get total H plus ion concentration, that is 0.51 mole. Okay. Then next one is to find the OH minus ion. So here only one strong base is there in our solution. So it is 0.62 mole. And we know that one H plus ion will combine to one OH minus ion to produce water. So here in this question we can take 0.51 mole H plus ion plus 0.5 mole OH minus in 0.62 mole OH minus ion. So from that we are only taking 0.51 mole because 1 H plus 1 OH minus gives H2O. Like that 0.51 mole H plus ion and 0.51 mole OH minus ion will give water. So after that we have remaining OH minus ions only, that is 0.11 mole NaOH. Please put a logic. Here it is a strong base and now we got 0.11 molar NaOH, that is OH minus ions only. So that our pH of the solution should be greater than 10 and it will be near to 14 because it is a strong base. Okay. So now we are going to find the correct pH of the solution. So next thing is to find out the pOH. So it is calculated by taking the negative log of OH minus ions, that is negative log of 0.11, we will get 0.96. So this is the value of pOH and we have to subtract this value from the pH, that is 14 minus 0.96, so we will get 13.04. So our answer will be 13.04. So you can see from this question, that is here two answers are below 5. So by looking into that, we can eliminate these options because we have a strong base. And from this, we have to choose the right one. By calculating the POH, we will get the correct answer, that is 30.04. Also, we can take a logic, that is, it is a strong acid, definitely it will be the answer. Okay, so moving into the next question. Sodium hydroxide is a strong base, which is the pH of, what is the pH of a 0.02 mole sodium hydroxide solution? So we have to find the pH of a solution with 0.02 mole sodium hydroxide. So again, it is a strong base. From the option, you can eliminate two of them. That is, you can eliminate these two, and only remaining ones are 12.3 and 12. So this is nearly same thing. So we have to calculate it. So for calculation, the same thing we have done before. That is NaOH, that is sodium hydroxide, is a strong base. When it dissociates, what will it be the result? It will give sodium and OH minus ions. That is, when every NaOH dissociate, we will get one OH minus ions. Okay. So 1 mole OH minus ion divided by 1 mole NaOH into the required amount. That required amount is 0.02 mole. We will get how much of OH minus ion in the solution? 0.02 mole OH minus ions in the solution. Okay. So again, here we get concentration of OH minus ion, not H plus. So we have to calculate POH, then pH. So again, we will calculate POH, negative log of 0.02. So we will get 1.7, and calculating the pH, that is 14 minus 1.7, we will get 12.3. So our answer is, answer for this question is 12.3. And we can look for some questions same like this. Okay. What is the pH for a 0.05 molar HCl? Okay. So in a solution, it contains 0.05 molar HCl and we have to find its pH. It is quite simple. You know that hydrochloric acid is a strong acid. So you can eliminate the values above 10. So I am going to eliminate these two. So now I have two values and I have to find which is the correct one. I have to find the value of I have to calculate the pH of 0.05 molar HCl. So to find it, the same thing we have done in the previous question. So HCl in dissociation gives H plus plus Cl minus. So for every molecule when it dissociate, HCl molecule when it dissociate, it will produce one H plus ion. So the same thing we are going to explain. If we get 2 H plus ion, we have to write here 2. Okay. So 1 mole H plus ion by 1 mole HCl into the required quantity, that is 0.05 molar HCl will produce 0.05 molar H plus ions. Here it is direct, that is we have got H plus ion directly. In the previous question we got OH minus ion, so that we have to subtract it from the 14. But here we don't want to subtract it from 14 because we got directly the H plus ion concentration. So we have to calculate the correct pH by using negative logarithm of concentration of H plus ion will produce negative log 0 of 0.05 will produce 1.3. So we will get the value 1.3. So the pH of the solution is 1.3. Okay. So the answer for this question is 1.3. Okay. We can move into another question. It is somewhat twisted. So this is a question. It is different from the previous questions. So please be careful. So what is the pH of a 0.04 mole solution of hydrofluoric acid? And it is given the equilibrium value, that is Ka value of 7.2 into 10 raised to minus 4 for hydrofluoric acid. So how to calculate this question? To calculate this, yes, in this question it is given that hydrofluoric acid is a weak acid, and when it is dissolved in water, the balanced equation will become HF plus H2O will produce fluoride ions and hydronium ions. And before the reaction proceeds, here in the question, it is given that the hydrofluoric acid is 0.04 mole. Okay. Since the water is a liquid and its concentration is irrelevant for the expression. So, when this reaction reaches the equilibrium, both the hydronium ions and fluoride ion concentration will have an increase, and we don't know how much it is increased. So, it is increased by an unknown concentration, and we can take this unknown concentration as X. At the same time, the concentration of hydrofluoric acid is decreased. Okay, and this by the same amount X. So, fluoride ion concentration and hydronium ion concentration is increased by an amount X, and at the same time, the concentration of hydrofluoric acid is decreased by the same amount X. Okay, now we can move into the calculation part. At equilibrium, what happens? Okay, at equilibrium, this is the equation we have to give. So at equilibrium, the fluoride ion concentration and hydronium ion concentration divided by hydrofluoric acid. So it is 7.2. It is given in the question. That is Ka value of hydrofluoric acid is given in the question as 7.2 into 10 raised to minus 4. So we know that now this fluoride ion concentration as well as hydronium ion concentration is increased by an amount X. So we have to calculate this X. Okay, so the amount of fluoride ion concentration and the amount of hydronium ion concentration. At the same time, here also you have to write like this 0.04. It is given in the question before the reaction, and after the reaction an amount is decreased. That is, we have to subtract that amount from the 0.04. That is, we have to subtract it. But when you look in this X for this value, it is very small, so that we can neglect this X in the denominator. So by removing this X, we can calculate the equation as this. That is 7.2 into 10 raised to minus 4 equal to X square divided by 0.04. Okay, so X square will become, you have to take this here in this part, that is 7.2 into 0.04 into 10 raised to minus 4. Then take the root of this value, you will get this, and rounding off 5.36 as 54 and taking 1 point this side. We are changing the decimal point to right of the 5, that is 5.4 into 10 raised to minus 3. Here it is 10 raised to minus 2. Not minus 2, it is plus 2. It is written in the denominator, so it is plus 2. Okay, so this X, this value is, this is X, and this value is equal to hydronium ions. So we have to calculate the pH of hydronium ions. Okay. So if you calculate the pH of hydronium ions, take the log of 5.4 into 10 raised to minus 3. So you will get 2.3. So your answer is 2.3. Okay. So the pH of 0.04 molar solution of hydrofluoric acid is 2.3. So this is all about this question. So I need a suggestion from you, that is, if you need my classes in Malayalam also, please comment that in my comment box so I can make some videos in Malayalam too. Okay, so please don't forget to like, subscribe and click on the bell icon so that you will get notifications. Okay, so bye bye.